Hello and welcome to our fourth day of the Energy Storage Digital Series week. I'd like to welcome you to our Storage and Urban Environments webinar, which is sponsored and moderated by NEC. My name is Maria Malduenda, and I am the digital series producer for the series this week. And I am also the host for today's webinar. Of course, I always like to start saying a big thank you to our sponsors, Clean Horizon, EDF, and NEC. As I've mentioned before during the week, this panel is part of a much wider series organized by Solar Media. And if you don't know us, you might know our online publications such as PV Tech, Energy Storage News, Current News, and Solar Power Portal. To see our full portfolio, subscribe to these publications, and register for other online summits, please visit solarmedia.co.uk. Before we start, I'd like to mention two big to consider this week. Do not forget to log into the Meet Me Zone. This is the best place that you can have to meet other participants, meet new partners, and future suppliers. Another thing to remember is to please submit your questions to the moderator on the right-hand side of the screen under the Questions tab. These will be answered at the very end of the session. And with that, now I'd like to welcome our webinar moderator, Mr. Roger Lin, who is moderating the discussion and sponsoring this panel. Welcome, Roger.
Hi, thanks, Maria. Thanks for having us. So I guess I can kick things off a little bit. A little bit about me first. I've been working in the energy storage industry for the past 8 years, but have been in the lithium-ion battery sector in a number of different roles for over 15 years of significant experience with batteries, especially lithium-ion. My focus is stationary energy storage, and at NEC Energy Solutions, I run global marketing and strategy, but my background is actually material science and engineering. Joined a small lithium-ion MIT spin-out company shortly after getting my master's degree there. And that helps me as I sit on the NFPA 855 Standards Committee for Energy Storage Safety, something I always felt is very, very important to the industry. I also serve the industry, and I'm honored to have recently been elected to serve on the board of directors at the ESA Energy Storage Association, and I'm also a board member at the California Energy Storage Alliance. So I'd like to bring on the rest of my panelists here to join me on stage. First, I'd like to bring on Peter Protopappas. He is the Director of Business Development at Llp On-Site Partners. So welcome, Peter. Also, Tom DeLucia, who's the Director of Product Compliance and Safety, also at NEC Energy Solutions, a longtime colleague and friend of mine. And then David Giroux, Engineering Project Manager at NLX North America. So welcome, gentlemen. I think how we'll run this panel session today is maybe I'll start off with some opening remarks, and then I'll hand it over to each of you to give a short introduction about yourselves, and then sort of make your opening remarks. So today I'm happy to be joined by this expert experienced panel, which is on storage and urban environments. As we all know, electricity sector is undergoing transformation right now. More and more PV and wind get installed, which is clean but variable, and less and less thermal generation continues to operate, which is dirty but controllable. So this gives rise to the asset class that is, of course, energy storage, while we're all here this week at the Energy Storage Summit. So as energy storage continues to grow, last year actually was a down year, in fact. About 2,700 megawatts was installed last year, but that's about 20% down from 2018. It's unfortunate, but most of this was due to challenges in safety with a significant number of large-scale fires, mainly in South Korea, where improper energy storage system integration and careless installation practices caused over 24 major fires. And this is a great concern to us in the industry as we're trying to get this energy storage asset class deployed. However, this year, in 2020, we're expecting a bit of a rebound as storage becomes a go-to resource for many parts of the US, UK, and the EU. Just an example, here in the US, energy storage is part of the plan. Here in Massachusetts, where I'm based, we have a 1 gigawatt hour target to deploy of energy storage by 2025. I think New Jersey has about a 2 gigawatt target. New York has a 3 gigawatt target by 2030. And then just very recently, Virginia put in place a 3.1 gigawatt mandate of energy storage to be installed by 2035. So it's now part of the toolkit. We're going to start seeing a lot more storage get deployed. So as prices continue to drop and the power sector continues toward less carbon emissions, more PV and wind and variable generation, and along with it, the need for flexibility, we'll see energy storage deployed in ever greater numbers. So while a lot of it can be in remote areas, like next to a wind farm, next to a solar farm, more and more we're seeing storage sited closer to where people are, urban environments, cities and towns. So for instance, in New York City, Con Ed, the major utility there, is currently putting in 300 megawatts of storage. In fact, we've already installed several installations in New York City over the last few years, all lithium ion and all very safe and with the approval of the FDNY. And we'll talk about those projects in a little bit. Overall, NEC Energy has installed quite a bit of energy storage over the years. Our first system was installed in 2008. We've got about 12 years of operational experience. Our strengths are in energy storage safety, reliability, and quality, and the controls that manage it. We've recently been contracted to build 2 50-megawatt systems in Northern Ireland, and over the years we've installed storage in the EU, China, Japan, and other parts of Southeast Asia, down South America, Chile, Brazil, Colombia. In total, installed or contracted energy storage projects total nearly 1 gigawatt worldwide, and we're one of the top 3 energy storage system integrators in the world. So as more of these are put in place, safety is obviously paramount, and we're talking about tens or hundreds of megawatt hours of energy storage in one place. It's like thousands of EVs stacked directly on top of each other, but with much higher energy density. And while a small lithium-ion battery like that found in your smartphone or laptop that you guys may be viewing this webinar on could cause a problem and maybe catch on fire, it's nothing compared to what might happen if a battery that's 1,000,000 times larger does. And as it's located in your office building, in the basement, on the roof, or an adjacent lot, or in any case close to people and property, it's very big and it has to be made and ensured to be safe. So the panel here today will discuss about putting storage in urban environments, why it's important, why it benefits the grid, both the utility and the loads, the people that need the electricity. How do we ensure it's safe enough to be installed in those locations? And then we'll talk about a few examples of storage in urban environments and the value they're bringing to the grid. So I think maybe what we should do is start off with Peter. Maybe if you could introduce yourself a little bit, a little background on yourself, AEP On-Site Partners, and then talk a little bit about storage.
Sure. Thank you, Roger. I came to On-Site Partners about 5 years ago when On-Site Partners was started. I have a background in, started my career at DeWalt Power Tools and Consumer Electronics in battery design and packaging, working with lithium and nickel cadmium cells. It was about, 10, 12 years ago. Fast forward, spent some time at the Department of Energy with building codes and standards specifically to battery chargers and power supplies, and most recently got into larger stationary applications for customers at AEP when we started AEP On-Site Partners about 5 years ago. AEP On-Site Partners is located on the competitive side of AEP's business, and specifically we focus on customer-sited solutions where we build, own, operate, and dispatch the asset on behalf of the customer over a long-term agreement. As it relates to energy storage in AEP currently owns and operates close to about 100 megawatt hours across our kind of footprint. Most of that is grid tied. We do have some solar plus storage, but as it relates to storage in urban environments, we focused primarily, our initial play here was in Hawaii. We have about a megawatt of energy storage located at University of Nations in the Big Island, and then at a smaller site on Oahu. And those applications are tied to solar arrays with the load shifting, but those applications are sited in and around those campuses where folks are living and breathing their normal daily life. And we operated those for about 4 years with no issues. As it relates to my current work, we are focused primarily on serving large-scale C&I and municipal customers. And as that relates to municipal customers, there are specific reasons why they're interested in storage and challenges as it relates to siting it along their distribution system, specifically with local stakeholders in their communities. So excited to be here on this panel today, and I look forward to discussing specifically those challenges.
Great. Thanks very much, Peter. So why don't we move on to David Droz. Can you give us a brief introduction on yourself, about NLX, and maybe your opening remarks? Thanks.
Sure. Good morning, everyone. My name is David Droz. I'm an engineering project manager at NLX. Our team is based in New York City, and I help manage and deploy mostly energy storage assets throughout the Northeast, New York, mostly New York City, Long Island, Connecticut, Massachusetts are really our most active markets today. And our solutions do span beyond energy storage. Flexible solutions and DERs are really what we view as a portfolio of available options for commercial and industrial customers, which is our focus in e-industries, but we also have verticals in e-mobility, e-cities, and e-homes. NL North America also encompasses NL Green Power, which is developing much larger utility scale projects, and just overall around the world doing a lot of great work, as NL is the largest, I think, owner-operator of renewable energy assets in the world. So our piece of that is, again, pretty small, focused on energy deployment in New York City, where we've been trying to figure out how to address a lot of the challenges for installing in urban environments. So I'm excited to talk with everybody about that today and address questions. My personal background is in mechanical engineering, done a lot of work with project management, first on the aerospace side as a design engineer and sort of flight test coordinator, and then got into wind, microgrids for telecoms and off-grid base stations, and then ultimately joined Demand Energy shortly before they were acquired about 3 years ago by what became NLX. So worked also at Con Ed Solutions on demand side management and demand response. And yeah, I'm just really happy to be here today. Thanks, everyone.
Yeah, great. Thanks very much, David, for that. And then our final panelist here, Tom DeLucia, Director of Product Compliance Safety. Maybe you could give us a little background on yourself, what you do at NEC Energy for the audience.
Sure. Thank you, Roger. It's a pleasure to be here. My name's Tom DeLucia. I have a kind of a long career in different areas. I've been in energy storage and vehicle electrification since 2009. But prior to that, I actually started out in analog design and control systems, and started out in in-circuit testing, in-circuit testers, and then moved on to actually doing some military defense contracting and work, which ranged everywhere from navigation and control systems to gimbal systems, and then off into some communication systems. And then went from there to data storage. I was there for several years, and then I graduated to energy storage. So that's kind of how I ended up where I am today. And my responsibilities at where I am presently at NEC, my responsibilities are product compliance and safety. That kind of encompasses a lot of things. It encompasses, of course, safety for our products, which would be complying to standards and so forth. Also, we're also groups responsible for hazardous materials, environmental compliance, RoHS, REACH, those types of things. We also get into a lot of, not a lot, but we also tend to get into some of the actual logistics at times. We're kind of a consulting group, if you will, kind of a catch-all in some cases. I've been fortunate enough to be on numerous SAE committees, and then I'm still on several of those, even though I'm not really in electric vehicle electrification now. but I still participate in some of those. And I'm now I'm the alternate actually to Roger on the 855 committee. I'm on the IFC group that's working on ESS, energy storage. And then I've been fortunate enough to be on the standards UL 9540 and 9540A standards. UL 1973 was recently asked and now involved in a CSA standard for BMSs. And there are several IEC standards that I've worked on as well. So I've been fortunate enough to have a pretty broad background, and recently I've just been pulled into managing our mechanical engineering department, and I truly manage it. The mechanical engineers run the show there. My background is electrical engineering, so I don't claim to be a mechanical engineer. Mm-hmm. So thank you.
Great, yeah, thanks very much, Tom. And we're fortunate that Tom is able to spend so much time poring over these very lengthy, very dry, very tedious standards, and then interpreting them for us in a practical sense, so that we can actually get some stuff into the ground. So thank you very much, Tom, for serving on all those standards committees and helping us understand what it all means. So, if there are any questions on standards and codes, you've got the right person on the line with Tom. We've also got Peter and David here with experts on deploying energy storage in various locations for various purposes and how to get projects in the ground. So we'll talk a little bit about that. I think one of the things we want to start out with, however, is just what are some of the main applications of energy storage in urban locations you're seeing today? Maybe Peter, you can talk about one or two of the projects that you have, and if you have anything you want to share about those with us. You might be muted,
Yeah,
Peter. There you go. No, you got it.
Am I unmuted? All right. So AEP on the competitive side, we serve supply across PJM, MISO, SPP, and ERCOT. And so if we focus on those territories and specifically municipal utilities who own their own distribution, we see some interest and some pretty valuable applications behind their meter. So that's behind the distribution meter for the utility, for the distribution utility. Those utilities pay their transmission fees and their capacity fees to those regional transmission and independent service operator territories. And so what we're seeing specifically in PJM is an ability to dispatch the battery against or arbitrage against those distribution or those delivery charges to the distribution utility, and then also participate in the ancillary markets. So specifically, regulate frequency regulation, for example, in PJM. What that allows the customer to do is utilize the battery for those specific time periods where their capacity or those peak charges happen, but then the rest of the year the battery is sitting there so it can play in the ancillary market. One of the keys, though, is that those municipal utilities cannot export most of them cannot export based on the tariff or the agreement they have with their transmission authority. So I think David's going to get into this a little bit further, but specifically constraints around limiting the battery to make sure it's sized correctly so that it does not export during some of those market operations. What's interesting about these distribution utilities are typically they're owned by small cities, small, medium cities. So where their grid is where their folks live and where their businesses live. So while we may not be siting it on an end user for them, we're siting it on municipal land, which indefinitely is surrounded by the city. So, challenges like how do we drop in containers with a web of distribution transmission lines ahead? If we have to drop the lines, how long do we have to drop those lines? When we bring in and if we're going to close roads, for example, how long are we going to close that road to facilitate some of the containers kind of getting dropped? So those are the primary issues we see in terms of logistics. And then, as we get into the safety discussion, there's other nuances to working in the Midwest and some of these other territories that are very unfamiliar with energy storage.
Yeah, great, thanks. So as we get into this discussion about deploying it safely in urban locations, I think one of the things we might want to touch upon early on, and we actually have a question already, is on safety and how important it is. How does one ensure the energy storage system is safe? What do you have to take into account when you put a system in place? Maybe Tom, you can give us a little background on how does one actually ensure that, and maybe touch upon, while you're doing it, some of the lessons learned from some of the other accidents that we've seen happen in other projects around the world. I think that a lot of what we're doing here is going to be best practices based off of what goes well, but also what does not go well. So maybe Tommy gives a little background on energy storage and safety.
Sure. When I joined the energy storage group, A123 NEC, there really were no standards. And our first system that was implemented, we actually cobbled together with an NRTL. We worked with TUV. We basically cobbled together what we felt was what would bring together a safe system with the standards that were available, and then we of course built on to some of those standards. And some of that was you need to understand the characteristic of the cell, the module, the rack, the components that you're using. What to what extent, what level can you push those cells? We did a lot of testing on the cells, and we brought them to failure. So we had we knew where their breaking point was, and we knew where to stay, what to stay away from. Now there are, of course, there are some things that you can't test away, and if you will, and that is if you have some flaw in your manufacturing process and you get an internal short somewhere, there's not much you can do about that. Now you have to you need to put in protective systems, but you have to have a process, a clean process by which you're building your cells, you're putting together your modules, so on. Once you understand all that, then, like I said, you put in place your safety standards, and like I said, we cobbled together some. Fast forward a little bit, the industry caught up. So now we have UL 1973, which covers the cell, the module, and the battery rack, depending on how you do your components. And then 9540, of course, covers the system level. I look at those as the minimum set of requirements. Some go in looking at those as, okay, this is what I have to meet. We kind of take a different view of that. There's the minimum. What else do we need to do, and what practical things can we do to make our systems safer?
Now, what would you say about the lessons learned from some of the accidents that we saw happen in South Korea? And I know you were involved in helping those guys figure out what went wrong in some cases. So maybe you can summarize what we learned there.
Yeah, and what we found in some cases, what we found was not enough detail, I'll say, adherence to some of the more practical things. For example, laying out cable. When you're putting cable in cable trays and so on, you tend to stack cables. Well, heat starts to generate and starts to build up in those cables. So you need to be conscious of the fact that you have thermal characteristics that you have to be looking at. Also, if you have a container where you're pulling it fresh air in, you will tend to pull in, obviously, it'll tend to get humid. You might pull in a salt atmosphere. So now you have to be careful of contacts being compromised. We saw some of that, which really hadn't been expected in some cases. That's why a closed system, if you will, is a good thing to do if you can, or if you're going to pull in outside air, make sure it's being conditioned. The others are running outside of your limits that you need to maintain. one thing, and probably we were going to get into this, but I might as well jump into it ahead of time. Some of the things that we learned ourselves was, from a reliability standpoint, you'd like to, you want to know where your voltages, your temperatures, and your currents are. And, so now we're looking at that from a reliability standpoint. But then some of the smart folks started looking at that and they said, there's big data or data analytics, whatever you'd like to call it. They were seeing patterns occurring here. And they said, hey, let's take a look at these patterns. And through some machine learning algorithms and so on, they were able to piece together actually cases where cells and or modules were either nearing failure or were swelling, and that would allow them to either proactively take those racks and or sections out of use until they could be inspected, or could monitor them and maintain safe operating limits. So it's an evolving process. We're all learning, and I hope we never stop learning. But we do need to put an emphasis on the safety and different ways to maintain safety. I hope that answers the question.
Yeah, so kind of like a lot of configuration issues and installation issues, carelessness in installation caused some of the issues, carelessness in design.
Yeah.
Pulling in outside environments that could cause short circuits or other issues with the battery systems inside, which are running at pretty high voltages. I guess one of the other things you mentioned was the ability to detect problems before they become an issue, and how algorithms that we use in NEC to detect conditions that may lead to hazardous conditions can help prevent things from happening, from going wrong. And so if they were available or were in place in some of these installations in South Korea, then some of these fires would never have happened. I'll ask the other panelists if they have any commentary on this. I know you've all heard of the issues that we've had in safety in other parts of the world. None of them involving any of the projects or installations that any of us on the panel have done, obviously, but maybe some thoughts or comments on that.
Yeah, I'll say that one way to think about this is from a detection and suppression standpoint. So how do we detect if there's an issue? And then if there is a fire, how do we suppress it? And the standards for 9540 and especially 9540A are really intended to help the design process. One of the things about the NEC system is the integration between the alarm system and the battery management system. And that allows for like what Tom was talking about, this sort of early action, and also the ability to make sure that you're monitoring the system for from a preventive maintenance standpoint. So I'd say those are from a high level, the standards are there to inform what we need to do in order to design the right or the best that we can detection systems, and then the suppression systems to go along with the batteries.
Yeah, and speaking that we're talking about, are they only applicable to lithium-ion batteries?
Primarily, but Tom, maybe you want to touch on that.
No, I was just going to say, Dave, thanks. All I was going to say was that, yeah, we're talking about lithium-ion here, but the standards were intended to be generic, depending on the chemistry and so on. So if you're going to, even if you were going to some kind of a flywheel type energy generation, the standards are meant to be adaptive enough to cover that. It takes a little work because it's not mainstream, but again, the NRTLs are really come up to speed very quickly with this, and are able to adapt to the different methods and chemistries that are being deployed in energy storage.
Great. Yeah, I'll take the opportunity here just to mention that there are resources available that were uploaded as part of this particular webinar. On the main website for the Digital Energy Storage Summit, you can go look under resources and find some presentations Tom and I have uploaded a presentation that covers a lot of different safety features that we feel are necessary for most large-scale energy storage systems. And in that presentation is a list of the primary standards that people should look forward to ensure their system will comply with the best practices known to date. And so again, that's available on the resources tab in the Energy Storage Main Summit website. Maybe we should get back into some of the practicality of this of installing energy storage. Maybe for David and Peter, in your experience as a project owner, how are systems installed and commissioned? Maybe talk a little about how did that process go for one of your projects in an urban environment? And maybe David, why don't we start out with you?
Sure. For this sort of high level, I want to bring up these slides. I'm not seeing those control. There they are.
Okay.
So just to take everybody through at a high level, I thought it would be good to see what this looks like, right? Everyone can get a sort of tangible sense of the scope of one of these projects. This is the largest battery in New York City that we installed last year. It's just under 5 megawatts nameplate and 3 of these NEC 53-foot containers, the GSS system. So, this is what it looks like when it's done. But we start with delivery. So site logistics is a big consideration. This is what the inverters look like when they arrive on the back of a flatbed. The container itself gets trucked into site. And then, of course, we have to pick it up and put it into place. The electrical work and the switch gear, wiring up the transformers. And I like this picture because it shows our point of interconnection. Every project has its own challenges. This is what interconnection points look like sometimes. And so they can be all kinds of underground, overhead, new service, and metering is a big part. And Peter touched on it earlier when it comes to sort of where the meter is and how you're using that interconnection position or point of common coupling to exercise the asset in the marketplace. The metering, as I mentioned, so this is a nice shot inside the switchgear with CTs in place for utility inspection. And then, of course, training. Safety is a huge part of what we do, both at NLX and NEC. And so training, operations training, preventive maintenance training, and safety training are sort of where I want to close out. So I hope that gives everybody a photographic sense of just what the scope of an installation would look like, and we can address any questions specifically about any of those components. I wanted to, so there's obviously the permitting aspects, there's the construction aspects, the commissioning. So I'll leave it at that, and we can address any questions. And Peter, maybe you have some additional thoughts on implementation.
Sure. So I like where you ended that, and you covered a lot of the basics of getting to commissioning and getting to operation. I think you ended with training, and as it circles back to the safety discussion, I think a lot of the instances of safety events or thermal events were exacerbated by the lack of training or the lack of following the protocols for training. And so I think one of the things that we emphasize when we talk with our local jurisdictions and the fire chiefs is, you have to have a process here. You have to have your folks follow the process. If you don't, or if you open a bay or you open a container and there's a release of gas, that could have been avoided. And so I think, part of commissioning and part of that is absolutely training. And then as you think about implementation, you're sizing the battery, you're sizing the system based on historical loads, potentially with projections of loads, and those loads change. And as you go through the life of the battery, whether it's 10 or 15 or more years, those conditions will change. So it's really important to revisit those anticipated load changes, load limitations. To your point, metering. Where's the metering? Is it still in the correct spot? And those things are constant. So this is a living, breathing asset, and I think that it's more emphasized on safety, but it also has to do with, you know, operating it within the expected bounds and within the limitations of whatever load it's serving.
Mm-hmm. Yeah, great point, Peter. So going back to your time, happens if there is an emergency, and you talked a little bit about emergency response preparedness, training for the situations, etc. One of the things that, you know, I think is potentially lacking again is first responder safety, and I know we've had issues in our industry where we've seen accidents happen and first responders get hurt. Maybe you know, we can talk a little bit about how do we keep those first responders safe. What do we do from a training perspective or a safety feature perspective to keep them out of harm's way, but allow them to do their job? So I'll kind of open that up to the panel and let folks comment.
I can start, I guess, on that if you'd like. That's kind of where 9548 comes in, and that there's always been a need, if you will, to determine or to decide or figure out, you know, when a battery fire happens, because unfortunately they will, and they have. What exactly is being generated? What occurs here? And so and because of some of the testing that had been done by ourselves, of course, New York City's done some, DNVGL has done a lot of work. We know that the gases given off, specifically from lithium-ion batteries, can be explosive, and the fire is burned very hot. So, make a long story short, the evolution of 9548 came about. It's a test method to look at the cell. It's a methodical method to look at the cell, the module, and rack level and installation level if needed. The cell level is primarily tested to determine where thermal runaway occurs, venting and thermal runaway occurs. In some cases, venting happens first, and actually in some cases, thermal runaway happens first before even venting, which is depending on the technology of the cell. But again, that information is used for gas concentrations and gas types, if you will. Then testing goes on to the module, and at the module level, similar testing is done for gas accumulation and so on. Also, heat release rates are recorded here as well. And in the interim, and you'd have to read through the standard, but there are conditions. Let's say you test your cell, and the cell doesn't go into thermal runaway, or it doesn't fail any of the criteria, which would be gassing or fire. At that point, your testing's done, because there is no condition that would be hazardous to the first responder. You go to the module level, you test the same, type of same thing. You see where you are if you meet the criteria of the module. If you do not meet the criteria of the module, then you need to go to the rack level or the unit level test, and you do your testing there to see where your criteria is. If you don't meet that criteria, now you get into unit level testing, which is okay. And David touched on this. What are your suppression? Techniques that you're going to use, and you need to test those techniques and show that they work. And from that, you've collected this information. It also gets into, okay, now I know what my gas accumulations are. I know I have an explosive atmosphere. How am I going to protect that? Am I going to do it through, say, deflagration or explosion control? Am I going to do it through dilution, if you will? I'm going to vent it. So you need to, you take these separate approaches, and that all leads to, again, first responder safety, because you need to be able to provide that to the first responders. Also, give them idea of what's happening inside of the container, if it's a container or a building, what gases may be emitting, a way to vent that. We have a manual vent fan, if you will, in our containers. So it all builds to how do we keep our first responders safe, and how do we keep our subject matter experts safe, because they're the ones who are going to be called and giving advice. So yeah, I think it kind of builds from there.
I think there's a lot of different things that can be done. And obviously, as we've all done projects on the panel, all of us on the panel done projects in cities, New York City or others. We realize that New York City is a pretty sophisticated jurisdiction, but not all cities will have this level of sophistication. So maybe we could talk a little bit about how does one approach a local jurisdiction who has never cited energy storage in their community and doesn't really have any specific siting ordinances. And as a corollary to that, how do we then educate the local fire department who has never thought about or dealt with energy storage systems before? So maybe we'll maybe start off with Peter on that one, and then go to David.
Sure. It's interesting, and what I think we've found is that we are automatically put into the stewardship role for the energy storage industry, and so what that means and what we benefit from is your work, Roger and David, or Tom, on NFPA 855 and the thoroughness that was done for that. So, luckily we have that. We have the stewardship of New York City Fire Department and the work that you guys have done with them, and we point those stakeholders at the cities, the fire chief, to 855, and we also involve them in every aspect of the project. And what that does is gets from the beginning, they're very apprehensive. They don't know what's going on. They don't know even what questions to ask. But by the time they are able to get 855 in their hands, by the time that they see the equipment going in, and as long as they are part of the process all the way, that really allows them to create their own informed decisions and how to deal with it. And I think, that helps with permitting. It helps with access. It helps with the first responders when you provide them with materials that are already there to develop their own processes. And I think that's really important to get them involved early on.
Great.
Yeah, I think that was actually very well put, Peter. I've seen a lot of adversarial responses in dealing with local AHJs, and that's been unsuccessful. And collaboration and involvement and open communication, transparency, education, training. From an operations standpoint, where we sit is really from a practical standpoint. What are the scenarios? What are the hazards that we characterize as a result of the testing, or can be characterized as a result of the testing? Having the right signage is a big focus for us, so that when a first responder who may not have had the appropriate training, because there are a lot of first responders out in the field that are aware of batteries or might have had some training on batteries, but you're still showing up to some kind of an emergency situation, and you need to know what's going on. And so giving that first responder very clear direction on site, having them in contact with representatives, or making sure that they're able to contact the right representatives, the subject matter experts, is really important as well. And collaboration.
Yeah. So, on the topic of communications, I know, at least here at NEC, we've deployed something we call a battery condition enunciator, which is actually a mobile app that can be used with first responders to show up, scan a QR code, and figure out what's going on inside the battery container without actually having to look inside the battery container, which is a nice thing. We want to keep physical distance if there's a suspected issue inside any large-scale lithium-ion battery, or any other large-scale energy storage device for that matter. So I think, David, I'm not sure if we deployed it with you guys yet, but it's something that we have discussed in the past. And I think first responder community has responded well to the availability of this pretty simple application. Yeah,
we're really excited about it. So is the FDNY.
Yeah. In fact, I think one of my contacts actually suggested it to me a few years back when we were starting out with on the 855 committee, and we've got it to a point where now it's starting to get rolled out to all of our installations, especially those in urban areas. So I think we're thankful that that's going to be rolled out and likely mimicked by a lot of different integrators out there. So maybe we can get into some specifics on challenges you guys have faced in the field. How are they complicated in a city install? Things like safety, subcontractor coordination, site access, staging, logistics, permitting. or other challenges you face in installation in urban areas that impact the local community. So maybe David, will go back to you on that topic.
Yeah, and I'll kind of keep this brief. Those bullets are a quick overview of a myriad of challenges that we face in implementation. I think permitting is a big one for us in New York City, and as we've been discussing, the safety. So making sure that the right jurisdictions are involved, ministerial and non-ministerial permits. Well, what does that mean? Who actually has jurisdiction? Who is the AHJ, the authority that is going to say that you have permission? Utilities are often a big part of that, and making sure that from a development standpoint, you're also collaborating with them early on. So a lot of the challenges are really about this chicken or egg that happens in every battery deal that probably many on the call are familiar with, which is sort of, what am I deploying? How big do I make it? Where do I put it? How much does that land cost? What's the deal structure? How risky are the revenues? And then from an operations standpoint, putting that all together into a package that we can contract and build. So that's sort of the front end. And then the back end is from an energy market, what we call energy market standpoint, which is once you actually commission the system and put it into operation, right, closing all those permits that you worked so hard to open, making sure all those inspections are finalized and tied up, and then actually operating the asset so that it matches your revenue projections, happens also as part of operation. So I think altogether, those are some of the challenges. I'll kind of leave it at that. You guys can put in additional questions, and we can touch on anything that we want further from there. But that's from a high level. Those are the kinds of challenges we face.
Yeah. Peter, anything to add from your perspective?
No, I like that answer, and I'll echo it. What I'll say is, a lot of times we talk about energy storage as this new technology that has a lot of unknowns, and that is true. But when you think about urban environments, and especially as it relates to my company and what AEP does in terms of distribution systems, there are precedents that have been set in urban environments with high voltage, high risk, and quite frankly, dangerous equipment if not handled properly. And I think if you build off of those principles of substations or transformers that are already in those environments, and then add into it, technologies like what you just mentioned, Roger, looking inside, I think that's awesome. Those things specifically kind of abate a lot of those challenges, but it's specifically to commissioning in urban environments and installing the batteries. I would say access is a challenge. When not only, Dave, you mentioned where you interconnect, right? I mean, a lot of these customers, you're having to potentially rip up part of their parking lot or rip up, their access, a new road. All those things are initially met with uncertainty, and quite frankly, folks don't want anybody to see it first off the bat. So how do you site it where you can balance safety, site access, and minimal disturbance to the local community is something we focus on as well. And so all those things are front and center. And when you think about some of the, we at On-Site Partners have over 60 systems with municipal utilities and solar, and a lot of those are in open fields, or they're 6, 12, 20 acre solar farms. When you're putting it in an urban environment, there's a whole host of challenges and things you have to consider that a lot of these developers just aren't used to. And so, working with that environment is unique, but it's a lot of other technologies in the energy space have paved the path.
Right. Perfect.
Yeah, I'll just chime in there because I like that also. And when it comes to the area being a premium in urban environments specifically, I know that's what this session is really focused on, timing and coordination. So scheduling becomes a big part of that. Long lead items like inverters, transformers, the batteries themselves, those become a really critical part of the implementation schedule, and so that you have a place to put them when they're on site, either to stage them if you can, or directly into where they're going to be installed. And so that choreography especially if you need to have special DOT permits or other permissions or other access, is a really good way to identify a particular challenge for urban environments.
Yeah, perfect. I guess one of the questions that comes to mind then, and I may regret asking the question, but David, in your experience installing that large battery system using NEC equipment in Brooklyn, what were some of the biggest challenges in getting that equipment in place, from any of the different perspectives that you mentioned before, scheduling, or was there an energy density issue? It's a lot too small, etc.
Yeah, we were lucky on that site to have enough room, but the biggest challenge that we faced was permitting. To be quite honest, this was installed at a time when a lot of the new city rule standards, NFPA 855 and 9540A, were very new, and so it was really just a critical path push to be commissioned by what was, for that project, a utility deadline, so that we could be ready to perform for summer demand response and load, like grid support, which is what the battery performs.
Right. Okay.
So timing.
Timing, yeah, makes sense. Obviously, with all these projects, timing for interconnections and going live and fulfilling the requirements of the contract are paramount. So making sure everything arrives on schedule sounds trivial, but it's very, very important, and is the cause of much of the controversy when putting a project in place. So maybe Peter and David, as an owner of energy storage systems, what do you look for when soliciting energy storage integrators and installers? What do you require of them, and what do you do yourself?
I could take that real quick. What we're looking for specifically is for that integrator and the original manufacturer of the modules to kind of stand behind the equipment. That means performance guarantees. It means being stewards of the safety standards, bringing us equipment that qualifies and has already been tested under UL 9540A, and making sure kind of all that stuff lines up. That's not something we do, but certainly as an AEP company and as AEP, all of the storage projects we go across our framework have to meet NFPA 855, and especially in urban environments, there are, as we may have discussed, special exceptions to distance and setback from public right-of-way. I believe it's 9540A is required to get a setback under. You guys are better at this. It's 8 or 10 feet, and then it's up to local jurisdiction. 10 feet. So now it's up to the local jurisdiction to whether or not they can accept that. So we look to the integrators and the operators to fulfill those requirements and cross those hurdles.
Great. So maybe it would be good to shift into the Q&A mode. We have another question here from the audience. Are there any quantifiable safety benefits of using LFP over NMC? And LFP obviously is a different type of lithium chemistry. It's lithium iron phosphate. NMC being one of the oxide category, nickel, manganese, cobalt. So maybe Tom, what are the differences in safety between LFP and NMC? We've obviously worked with both chemistries.
Yeah.
What's your opinion on that?
LFP obviously can have thermal events just like NMC can. LFP is, shall we say, a little less energetic than NMC. So from that perspective, at least in my view, there is an advantage there. But overall, if you take a look at some of the other manufacturers out there, they've actually been able to make NMC, which is a higher density chemistry. They've actually been able to make the case where there is no propagation within the module, and they've actually gone in even to the unit level and found that there's no propagation. So the industry is getting smarter Although, like I said, there's certainly nothing wrong with LFP. We've used it for a long time ourselves. There used to be the advantage, in my opinion, like I said, that it was a little less energetic. But quite frankly, there are things now overcoming that where I don't think there's that big of an advantage. I think right now what we're seeing is that some municipalities or so on feel a little more comfortable with it because it is a little less energetic. But there are safety provisions that can be put in place to control that.
Yeah, I'll just temper that just by saying that, when you're dealing with, single cells, very small, 10, 20, 30 watt-hour batteries using LFP, there's I think a more distinct advantage there. But once you get to the scale at which we're deploying these things in the grid, hundreds of kilowatt hours at a minimum, which is like 3 or 4 EVs put together, right? But all in a very small space, and up to hundreds of megawatt hours, that sort of washes out some of the benefits. It is true that LFP does have a higher temperature before it goes into thermal runaway. It is true that it has a higher degree of abuse tolerance, meaning you can abuse it a little bit more and it won't misbehave on you as easily. But when you, again, get to these, tens and hundreds of megawatt hours scales, the importance of proper safety, integration, and even prevention, keeping the batteries within the allowable boundaries, driving between the lines, cannot be overstated. We're talking about a very different scale of energy here, and it's very important that the system around it is able to keep things on track. We're reaching sort of at the end of our hour, and I think we had a great discussion. Maybe we can just go and do some closing remarks from our panelists on the topic. So maybe why don't we start with Peter, if you have any closing remarks you want to make about storage in urban environments.
Yeah, I think it goes back to the notes about collaboration. There are a lot of stakeholders, local stakeholders, residents, the cities, the end-use customer, and then the utilities. Getting everyone involved, getting line of sight on everything at the beginning, and educating those stakeholders is very key in storage in urban environments. I think if you do collaborate, it makes it a lot easier to get over the hurdles that we did talk about. So I'll leave it with that.
Thank you. Tom?
All I would say is wherever you're deploying, whatever state you're deploying in, what have you, make sure you take a look at that state's fire code, because they vary over a vast array, because not all states go to the most recent. So you really need to understand that. And it goes to education too. They may not have ESS standards, but we should be educating them to make sure that they realize they should have it.
Great point, Tom. Yeah, it's different depending on where you go. David.
Right, and they probably don't. My closing remark would be, trying to end on an optimistic note here. Firstly, a huge thanks to everyone for their participation in the panel. Is that this is very doable, right? There are a lot of challenges, yes, we've covered today and discussed, especially in urban environments. But there are a lot of resources out there. The integrators have come a long way in helping to deliver a market-ready and installation-ready technology that developers and installers can go in and make money from in the market in a number of markets around the country, which we're doing today. And so it's been incredible to sort of be a part of that. Very humbling to be a part of that and watch that transformation as it continues to accelerate, and we see a lot more storage deployment. So
perfect. Thanks, David. Yeah. So in summary, I think storage is ready for deployment, even in urban environments. Education is key to all this. Try and do the research on your local codes and standards for your projects. But if you want industry resources, you can always feel free to go to different industry association websites. The Energy Storage Association, or ESA, has some good resources, for the United States. And then locally, for instance, in California, the California Energy Storage Alliance also has some good resources collected on ensuring safety and getting through permitting and installation in your area. So With that, I'll close the panel. I'll thank my panelists for joining me. I think we had a very interesting and informative discussion. And Maria, I'll turn it back to you.
Thanks, Roger. I want to thank, of course, Roger for moderating and our other panelists for participating. Storage in urban environments is always a topic that we get requested to Solar Media to present. It's something that we presented on before and we'll always continue presenting in future events, both in person and on webinars. For those that are still tuned in, I want to remind you to stay tuned. We have another panel going on in 30 minutes at 3:30 British Summer Time and 10:30 Eastern Standard Time. It is arbitrage, making money from the merchant model. This is a really interesting topic moderated by IHS Markit. And it will have two specialists, one from the US and one from the UK. So join us for that discussion. So thank you again to the panelists and stay tuned for more. Thanks, guys.
Thank you.